Hello. Hi. Good evening, everyone. I'm audible. Hello. Okay. So today, uh, I'm going to take up very important topic, and the name of the topic is array. Basically, I can call this as the array in Verilog. Okay. This is very important topic. I can say that in your language element in Verilog, and after the data types, it is very important because why it is required, because if you want to initialize or you want to design anything which is related to the memory. Okay, now what is exactly a memory? A memory, basically it is a composition of data per location. Okay, that is data stored per location. So you have something like 8 bit of data, and that 8 of bit data is location in a number of location. Like for example, you have a 16 location, you have 32 location. So basically you have at every location that is one, from one bit to any number of the bit is data is saved. Okay, so to implement these type of things, basically it is required to have a better understanding of array, right? So so what exactly if we initialize array, or if we basically design array. So basically if I'm talking about FPGA, then this type of things will give you the will implement a memory. Okay, if you are going to implement this thing on ASIC, then this will give you some register bank. Okay, so like this register bank or memory is basically play a very important role because FPGA, if I'm talking about FPGA is not a non-volatile device, and FPGA is basically a volatile device, and FPGA is made up of RAMs. Okay, so RAM, basically a one-dimensional RAM, that is a data per location. So if you want to store the data and you want to process it, then definitely you require a RAM. So to complete this type of function, to complete this type of logic, you required a knowledge of array. That is how to initialize, how to design, how to implement this memory things on FPGA or for any application. So good evening, everyone. My name is Vaibhav Mishra. I am your instructor in this series, and the series which we are continuing from last 25 classes. Today is our 26th class. Okay, and today basically, sorry, not today, 26, not sorry, today is 11th class. Okay, and this is 11th class of Verilog, and session number, I can say this is session number 11. Okay, so today we are going to discuss more about the array. Array is very important, just like data elements, data elements, like we have read integer, we have read register, we have read real and real time. So this is, I can say, this is a second last topic under the language element. After this, we are going to take up, tomorrow. Maybe I will talk about the string, and day after tomorrow I will talk about the parameters. Then we are going to close this session, and after that we will start with either with the digital design, or we will start with the operators. Okay, so let's start with the slides. So again, why I'm going through with the slides, because in every class I used to mention this, because this slide will help me to focus on the topics. Sometimes you may be not able to catch me that what I am speaking or what I want to express. Then in that case, some statements will help you to understand, okay, what exactly sir is want to express. So with the help of PPT, I can save my time, because if I have to explain anything, I have to write and then I have to explain. So this is a time taken task. So we are using this board only for digital design, not for programming. In future, just from operators, when we are going to start the operators, we are definitely going to use our tool, Xilinx ISC or Vivado, to implement the logic. Okay, so let's start with the programming. Sorry, let's start with the PPT. Okay, so yesterday, last week, I finished with the vectors. And now after vectors, we are going to start a Verilog. So as I mentioned that I will go through a line by line and I will explain the meaning of every line. Okay. So what is array in Verilog? So array in Verilog is a collection of elements of same data type stored under a single name. Array are useful when multiple registers or memories need to be represented efficiently. So here means that array is a collection of elements. Okay. If I say a collection of elements. Okay, so collection of elements of the same data, that is your starting, that is for example 0001. Okay, so you want data that is or we call elements or element or we call as a bits. Okay, okay, or we call as a data. Okay, so this element, bits or data is stored under a single name. Okay, that is a single name means store matlab a location. Okay, so these are my location. Okay, so this data is stored in a location. Okay, so and this is of multiple types. Okay, this is of multiple registers or multiple location. Okay, so this is basically is called a your array. Okay, for example, so you have a data from 0 to 7 and you have a location of 15. Okay, of 15. 0 to 7 means you have data of 8 bits. So you want to save this data per this 8-bit data per location. Okay, so this 8-bit data per location. Okay, like this. Okay, so you have up to the 15. Okay, and these elements can be of different type. This element can be of same type. Okay, so this is for example, instead of declaring many individual register. Okay, now question is why we use array. Okay, instead of declaring this register means this location. Okay, register means location, a different location, a different register. Okay, instead of declaring this register or location, okay, of like for example we need a 16 different registers. Okay, then again this is a hectic job. Okay, this is a hectic job. So this, okay, data 0, data 1, data 2, data 3. So on one data zero, that is one location, you are storing 8 bits of data. This is a hectic job. So why to call 8 different or 16 different or up to 255 different location, okay, or individual register? Let's call in this. Okay, so here 7 is to 0 data, 0 is to 3. That means you have a 4 location or 4 registers where you are going to store this data of 8 bits. So this creates an array of 4 elements. See, I say 4 elements of 4 registers or 4 location which storing your data 8 bits per location. Okay, and I hope this is clear. Okay, again, I am trying to explain you with multiple examples. So please be with me and please try to understand. Okay, I have collected this data from many resources, from my book, from social media, from blogs, from PPT. Okay, and now very famous, that AI. So here now let's go with the syntax declaration. Sometime whenever you are going for the interview, this is an interview questions. Okay, do you know array? You say yes. Write the syntax. So have if you have not used the array in your design, then you cannot write it. But if you have used the array, then you know how to write it. Okay, so very simple data types. It can be your reg. Okay, again, okay, let me explain this PPT. Data types means your reg. Very simple. Okay, data types means your reg, integer, vector. Okay, real time. Okay, so there are two types of data types. One is connectivity, one is storage. Wire comes under the connectivity, and under the storage your reg, integer, real time. Okay, I have already explained all these things. MSB to LSB, 7 is to 0. Array name, okay, you can take memory, and this is start index and end index. मतलब start location and end location. So it can be your 255 to 0. Okay, so data 8 bit of data is stored in a 256 location. Okay, so some error. Okay, just a minute. Okay, okay, I just corrected it. Okay, so some some problem I'm facing. Sorry guys for disturbance. Okay, maybe I have to go through with this setting only. Okay, I hope this is visible. So, so as I mentioned, I was just trying to explain you that is how basically we declare the. So this is your data types. Okay, here you have to mention the reg. Okay, here you have to mention the reg, and here you have to mention your bits. That is a storage element. Okay, storage element that is your 0 to 7, and here you have to give a name, memory, and here you have to assign the location. That is how many location you have. For example, 0 is to 7. So this is a just declaration has two dimensions. So basically, what is two dimension? This is one dimensional. Sorry, this is one dimensional. That is data store in per location. So this is one dimensional. This is two dimensional. Okay, sorry, two dimensional is something you have more than one more array form. Okay, so this declaration has basically two dimension. So so you have a this is your elements. Okay, and this is your location. Okay, so your data is stored per element. Okay, data store per element. Your element or data store per location. Okay, so here red is your data types, data per bits or data per bits, data bits per element, or you can say a data also. And this is your memory, that is your array name, and this is your 16 array location or number of elements. Number of elements. Okay, so this is your total storage, that is a 16 cross 8. 16 cross 8. Okay, so please try to understand. Okay, so what is exactly now in more refined way? So what is memory array? So most commonly array in Verilog is a memory array. Just before this slide, I have just mentioned. So mention one more time. I am just explaining you. So this is your 7 to 0 means your data, and this. So just for example, a RAM. So RAM has a 15 location. Okay, so per location, how many data is saved? So this is your location 0 to 15, and data is 8 bits. So 8-bit data is stored in a per location, and this represent a 16 cross 8 memory. Okay, array is not a vector. Okay, many times even uh, myself too was always confused when when I was starting learning the Verilog. Okay, sometimes it's confused. Okay, because of the um, vector. Okay, so array is not a vector. So many beginners think that this and this. Okay, see, try to understand. Here you have a data first, and here you have this 15 is to 0 after data. Okay, so this vector before data and this, or I can say this MSB to LSB before data, and here MSB to LSB after data. So let me explain this. Okay, so this is basically your if you have declared the vector before any identifier. Okay, then basically it is like a number of okay number of, and if you are declaring this vector after name or after the identifier, then basically it shows a location, okay, or register, right? So here basically you have a 16 bit of data register, and here you have basically a 16 bit of data. Okay, so that means your data is stored in a number of location or register. Okay. Hmm. Again, just to make it more simplify, once again I'm trying to explain you, because I know the pain of the candidates. Okay, they always be confused. Okay, so here once again 7 is to 0 data. So data means your location. Okay, so you have location 0, location 1, location 2. Don't confuse. You can write it data oblique location. So per location you have 8 bits of data. So 4 separate 8 bits object. Okay, now array of vectors. Again, I am trying to explain again once more time this with a different specification, that is array of vectors. Vectors means again that you have basically a number of bits. Okay, if you remember what is vector, basically a number of bits in a single line. So it is differentiate between the MSB and LSB. So something which is higher side position and lower side position. Okay, so very common practical example, meaning that this has a 32 bit of register, and each register has 16 bit of 16 bits. Okay, so what is the where it is used in CPU, in microcontroller, or in DSP processor. Okay, in previous slides I have not given you the example of CPU or microcontroller. Here just a very basic example that how the basically arrays look like. Okay, so array of registers, again 8 bit, 8 registers of, and each register has a 4 bits of data. Each register has a 4 bits of data. Okay, array versus vector, very important. Many beginners confuse vector and array. Vector means this. Okay, see this bit 7, bit 6, bit 5, bit 4. Okay, that is your 8 different data. Okay, that is single 8 bit object. Okay, and okay, and what exactly a vector? What exactly a array? Array. I mentioned in the previous slide, that is this data. This all this data. If we are storing all this data, if we are storing all this data in in okay in other location, like this, like this, like this. Okay, so this is called basically a array. Okay, memory inference, again one of the example, because this is an interview questions, what exactly memory will do in terms of synthesis, or in terms of any, in terms of processor. Okay, what exactly the uh, memory will replicate, or what memory hard, or what hardware will generate by the memory. Okay, so during synthesis in FPGA, as I mentioned, it will work as a it will be basically configure a block RAM or distributed RAM. In ASIC, it will be configured as a SRAM macro, register bank, or depending upon the memory size, read-write operations, and technology library. Okay, you should know this. I have mentioned this because you should know this ki what exactly the memory will provide you. Okay, if you don't know what memory will give you in a hardware, then you cannot use it memory for different applications. Okay, so one of the project recently today I discussed with the candidates that he want a project with me. He, sir, please give me some project. So I told him, okay, you store your name, you store your alphabetical name in ASCII format in memory, and then display your name on either on your LCD or VGA or anywhere. So this is one of the application where basically your memory is used. Okay, next. Okay, so how basically you are accessing the means how basically you are reading the memory. Okay, reading and writing. Basically, this is very important. Okay, while because see when again I'll give you my example. During the starting days, I really uh, feel very complicated that how to basically read and write the memory. Okay, so this is one of the biggest challenge. Okay, so a student should understand that how to read the data and how to write the data. Okay, so I'm just trying to explain one basic syntax that this is how basically you are reading. So you have basically reading means you are basically the something which is stored at location. Okay, that data which is stored at location. And now you are basically finding that location and you are taking the data from that location. For example, what is reading? Reading means output. Reading means output outside. Okay, so suppose that you have data, you have a location 1, 2, 3, 4, 5, 6, 7, 8. Okay, so at this location 0, 1, 2, 3, 4, 5, 6, 7. So at this location you have something like data 8 tick uh, FHA. For example, this have AA, ठीक है, hexadecimal. Sorry, this is your hexadecimal actually, and this is your BB, your CC, your DD, your EE, FF, GG, HH. Suppose you have a different data at every location. Now you want to read it. Okay, so suppose that this is a RAM 0, this is RAM 1, 2, 3, 4, 5. So you want to read the data from this location. Okay, so basically you are calling this one. Okay, you are calling this. So what exactly on your location? You have basically the number of bits, your data. Okay, so basically you are calling this location. Okay, so you have called this location. Okay, so you have called this location. That is data out from the location number 5. Okay, so what data inside the location number 5 is 8HHA. 8HAA. That is your 10101010. Okay, so you have 8 bit of data stored at location number 5. So how this is basically you are reading it and writing it. Okay, reading and writing. Okay, so you have basically stored this 8-bit data on RAM 5, and here you are calling the RAM 5 data as the output. Okay, very simple. Okay. Mm, this is one of the example in terms of synchronous and asynchronous. Okay, in terms of synchronous and asynchronous. Now, what is synchronous? Synchronous design means something you are accessing in favor of or in presence of clock. Okay, something you are targeting to call out in favor of or in presence of the clock, that is called synchronous. So if your output is storing the data in the presence of clock, that is called synchronous output. If your input some control signal like reset, enable, preset, clear, anything, any control signal which is actually working after clock arrive, then it is called a synchronous. If any data control signal or any output which is not storing the output or any control signal which is not performing the operation in the presence of clock, okay, that is output is clock is not coming, but your reset has been done, so that is called your asynchronous uh, or asynchronous design. Okay, so here asynchronous means something your data is basically assigned, you are assigning the data not without, you're assigning data just without in presence of or without clock or anything where clock is not arrived, and you are basically assigning data. So this is called your asynchronous design. Your synchronous design is something, see here, always at the positive clock. So you have a basically a positive edge clock, and you are assigning the data. Okay, so in presence of clock. So this is called your basically a synchronous. So you can read here that output changes only at clock cycles, clock edge, and most FPGA memories prefer the synchronous. So synchronous is the best design basically because clock is one of the very important factor in synchronous. So without clock, no data will move. So because you are not present every time in front of your design to initiate the process. Okay, writing into the array, very important, always at the rate passage clock. Okay, see again one of the examples. So here basically you are reading the data. Okay, here basically you are reading the data out means output. Okay, here basically you are writing it. Okay, so this is just a one example. Basically you are writing with the help of one control signal, that is if control signal is high, you are basically storing the data on a address. Okay, basically you are storing the data on a RAM. That is, a RAM is what? Location 1, 2, 3, 4, 5. So at one location you are storing the data. Okay, so this is called standard write structure. Okay, we will discuss this example. I will show you just now that how this is basically a one program. Okay, I'm going to show you. So we have one design name, that is a reg file. We have a clock. We have a write enable, and we have a input address. Okay, so basically this address is again mm, this address, what this address is here mentioned. Okay, let me explain. Okay, so as I mentioned that you are writing something in this format, data in 7 is to 0. Okay, and let me, so this is your reg file. Okay, so basically okay, please try to understand. This is 8. Okay, right, this is of 8 bits, this is of 8 bit. Okay, and this is your 8-bit location. Okay, and this is of 8-bit of data, 8-bit of data. So basically we have to store 8-bit of data per location. We have to store 8-bit of data per location. Okay, so for this, इसके लिए हमें क्या करना पड़ेगा? So basically we have to take this 8-bit of data as the input, and see we have taken this. Okay, please remember this 8-bit of data. Okay, 7 is to 0. That is your D in of 8 bits of 8 bits. Okay, then we in this design basically what we are doing here, we are basically we have taken a address of 3 bit. 0 to 2 means of 3 bits. So basically what we are doing here, we are replacing this 0 to 7 with adder. Okay, this adder. Now what is this adder? Adder what exactly at this side? इस साइड पे क्या होगा? इस साइड पे आपका लोकेशन होगा. ठीक है, your location means your side. So basically we are what we are doing, this we have given as an input. Now the user has the right to store the data of 8 bits at any location. Okay, वो लोकेशन खुद डिसाइड करेगा. The user will decide the location of their own. Okay, here, so what I am doing here, or what this program is doing here, basically we are basically we are basically replacing this location with our identifier adder. Okay, and the adder is of 3 bits. Okay, so 3 bit means total 7 position, 000, 001, 010, 011. Okay, so you can see here, whenever the clock will come, okay, whenever the clock will come, your right WE means if anything inside the bracket, that means true. Okay, so WE, whenever W is 1, okay, you are basically storing the data, okay, at every location. Okay, at every लोकेशन. ओके, सो दिस इज ऑफ 8 बिट्स. ठीक है, ये आपका 8 बिट का डेटा होगा जो आप एवरी लोकेशन पर शेयर कर रहे हो, मतलब राइट कर रहे हो. ठीक है, एवरी लोकेशन पे आप ये राइट कर रहे हो. ठीक है, सो लेट्स सी द एग्जांपल. ओके, एंड देन फाइनली यू आर असाइनिंग द whatever the output, whatever the you are writing it, finally you are taking on output. Okay, so output is of 8 bits. Okay, let me show you. Let me show you with the working. My screen is visible or not? Let me check. Um, no, I think camera. Okay, I think no problem. Uh, some problem I'm facing. No problem. I will. Device not connected. Okay. So sorry guys, I'm not able to show you the design. Okay. No problem. So I want to show you the working, but I'm not able to connect my programming software with the screen. Okay. So in my next class, I will show you the demo. Okay. So let's move. Okay. So array indexing. Okay. So Verilog basically allows either ascending or descending indices. Okay. For example, either you are writing from 0 to 50, 0, 1 to 5, or you are writing 15 to 0. So basically, this is called a array indexing. Okay. Synthesis consideration, yes, this is synthesizable. Okay, but up to only this dimension. That is your bits per location. Okay, offer synthesis as a block RAM, as a RAM macro in ASIC or a register bank, depending upon the size and coding style. Okay, applications of array are widely used for RAM design, ROM design, FIFO buffers, register files, lookup tables, if you want to store data in a lookup table form, image processing, memories, DSP, coefficient storage, neural network weight storage, packet buffers, and cache memories. Okay. Interview questions. Now, what is the difference between a vector and an array? So, vector is basically a collection of bits. Okay, collection of bits, and array is basically a collection of variables or elements or locations. Okay, so example is 7 to 0 A, that is your 8 bits of data, and this is your basically array. So your 8 bits of data basically stored in a 8 different locations. Okay, which Verilog constraint is used to model memory? Very simple. So basically, this is your syntax. Okay, so here you can write. So this is basically a advanced coding which is written here, data with -1. So that we will later on we will take up. Okay, in after once I explain you the parameters. Okay, can array be synthesized? Yes, memory array are synthesizable and commonly inferred as a RAM, ROM, register bank by synthesis tool. In one line, a Verilog array is a collection of multiple data elements, usually registers, index, span, address, primarily used to model the memory such as RAM, ROM. What is the difference between memory depth and width? Okay, so this is your memory depth and this is your width. That is the 8 bit of data per location. So how much memory is represented? 8 into 256, 2048 bits. Why are array used in Verilog? To model the RAM, ROM, FIFO, register, etc. Can array be synthesized? Again, in different way. Yes, array synthesizable are one of the following primary ways to describe the primary structure in Verilog. Okay, so this is your basically a your some interview questions and some design based application which I have explained you. Okay, so I'm about to finish the language element, and after this, we will start with the digital design once again that we have finished with the adder. Then we will start with the subtractor, that is the theory part, and then mux, demux, decoder, encoder, 2s complement, multiplier, and divider. Once we will finish this, or my objective is that I will take up the Verilog design of every combination and sequential elements. Okay, so let me think how I'm going to proceed. Okay, if everything goes fine, definitely we will give you the best working methodology that will help you to understand both digital and Verilog in very better way. Okay, so this is all from my side, and I request you everyone kindly devote your time in learning this Verilog and digital because these are the basic elements if you really want to start a career in VLSI. Okay, so either in VLSI or in embedded or in PCB design, you should know basically the digital design very well. Okay, so this is all from my side, and uh, we will meet tomorrow and day after tomorrow also. Okay, so thank you everyone, and Jai Hind.